Hello everyone. So I hope you guys are doing just fine. Yes. So this video we're gonna talk about the area rule, but the next two videos they will be about the sine rule followed by cosine rule, and after that it will be the end of trigonometry. We will do. I have some nice question paper, or I have some nice question for the last video. So hang in there. Let's get started. So for a triangle, a triangle, if you were asked to calculate the area of a triangle, just something basic, we all know it, by heart. I think if you happen to have forgotten everything in trigonometry, not necessarily in trigonometry, you know, is the area of a triangle, which is half base times perpendicular height. So it is, we'll say that the area is half base times the perpendicular height, right? And the perpendicular height is a straight line that is perpendicular to the base, right? Cool. So for example, in this triangle ABC that I do have, if I was to be asked to say calculate the area of triangle ABC, I would say it's half base times perpendicular height. Of course, this is just the formula, and then for some space I have a half. My base is what? It's 7, and then my perpendicular height, actually I would have to find it by theorem of Pythagoras. I think it's highly doable, so we can just do it up here. If I do it really fast, right, you guys can just do it step by step, you'll see. But if you can do it like me, then follow on. So we're gonna have 10 squared minus 7 squared is equals to the height squared, right? And what we get here is 100 minus 49, which is okay, let's do it. 100 minus 7 squared, which is 49, it's 51. So this is height squared, therefore height is a square root of 51. And then here, then I would just say square root of 51. Then whatever answer that I get, that will be my area for this triangle. But what we're going to do today is something in relation to half base times perpendicular height, but we'll take it step by step until we understand the whole concept of the area rule. Cool. So number A, right, we are finding the area of what? The area of triangle ABC, right? And we will say what? We will say it's half base. Maybe let me go half BC, which is base, times perpendicular height, which is what? Which is AB, right? And now the question is, what is sine C? We have angle C here, which is what? 54 degrees. And then now the question is, what is a sine? If you have forgotten, sine is what? Sine, right? Sine theta is just opposite over hypotenuse. So this side is the side opposite to theta. I need that. Yeah, it's the side opposite to theta, and this is the hypotenuse of the triangle, which is the longest side of the triangle, of course. So let us do that. What is opposite angle C in this diagram? So what is opposite angle C? It's what? It's AB, right? It's AB. So therefore the opposite is AB. You're gonna have AB over what? Hypotenuse, which is what? Which is AC, right? And then let us move from here. We have sine C is equals to this. Let me just say this is the opposite side. This is our hypotenuse, AC, and AB. Cool. Now if we write AB as a subject of the formula, looking at what we have here, what we will do is we're going to multiply by AC both sides. Okay, so once we multiply by AC on our right hand side, the ACs are going to divide each other and we will be left with AB, right? And if we multiply AC on this side, we're just going to have AC and then sine C, right? And then the last step, so just hold on a minute. Actually, don't hold on for a minute. So now we will then say, therefore, let's go back. Remember, area of a triangle ABC is half times BC times AB, right? So now we were able to write AB as a subject of the formula here at C, right? Here at C, we were able to write AB as a subject of the formula. So we would then say that means the area of this triangle is gonna be half multiplied by BC multiplied by AB. What? But you know AB is what? AB is AC. Then you can say times again sine C, right? And then there we go. That is basically the sine or the area rule. I've been saying, you know, there are so many videos that I did cut because I was busy saying sine rule instead of area rule. But yeah, okay, cool. So you guys get it now. I want to go back to the triangle. Let me see what if you do. Okay, I want to go back to the triangle. So for now, let us forget about these units. I will just remember them. In triangle, there's this thing that we usually there's this way in which we would define sides, the sides of a triangle, right? So the opposite side, like you would look at the angle. For example, we have angle C. The side that is opposite angle C, it's going to be given the letter small c, right? So this will be small c, and then B, angle B, the side that is opposite angle B is AC, and then it will have a small b, and then BC, it's opposite angle A, and then it will have a small a. So basically this is how you would identify your sides of a triangle. And then coming here, then again you can then say you have half. What is BC? BC, it's A, half A. And then AC, what is AC? AC, A, B. And then, yes, it's A, B, and then sine C. Sine C. Right. I think we are actually done with the sine rule in terms of explaining it. Because now I want to show you something, but we will get to it next. But I want us to do it now. Let me just cook. Now you see, of course, this is the area of triangle. A triangle doesn't look like that. Triangle. It's fine. Triangle ABC. Right, we're getting half A B sine C. Right. So remember, a triangle, it has what? It has 3 sides, it has 3 angles. Okay, so you see A, B, C. I'm sure right now you are thinking what I'm thinking. So right here I will write 2 other, what is this? 2 other, formulas for area of a triangle ABC. So we would say area of triangle ABC. Let me go again. Area of triangle ABC. So look at this. Look, we have half AB sine C. Okay, then I could say another formula for a triangle, area of a triangle, it's gonna be BC sine, we have ABC, we have BC here. Oh, I forgot the half. So it's half BC, therefore the angle is gonna be what? It's gonna be angle A. I think with that you can already guess what the formula here is going to be, and that is going to be half. So we had this sine A, we had sine C. What's left is sine B. That means we will have AC and then sine B, right? And then you are done. I don't know actually what's below what's below these slides, but yeah, I think I've done something which I was gonna do later. But basically, in short, this is, these are the three formulas for the area rule, right? And if you had, let me maybe highlight this one and say that is 1, 2, and 3. And if you were to be asked to calculate the area of a triangle, and you just see like which sides you have, do you have an angle, which angle you have, and also the angle that you have, also like it sort of tells you how you're gonna get it done. But let's go on. I think I have a question here. I was like, what if you don't have a right angle triangle? Yeah, there's also another concerning thing, is because when you have a right angle triangle, it's easy for you to see, oh, this is my perpendicular height. But the question, of course, is now like, what if you don't have a what if you don't have what is this? Oh, come on, Molanto. What if you don't have a right angle triangle? So before I answer that question, I want to make you aware of something. So remember now how I identify my sides, right? This is angle A, it's opposite to BC, therefore it's a small a, and then C, small c, B, small b, right? E, small e, F, small f. Maybe let me make this F a bit more like a capital F. And then we have D, small d, right? Yeah. Now, to answer the question, usually we actually construct our own perpendicular height, right? And then here you would have a perpendicular height of this form, and then this, in this triangle, this will be your perpendicular height. In this triangle, this will be your height, perpendicular height as well. And then the calculations, they just continue, right? Cool. Let's see what we have on the next slide. Oh, this is so interesting. I don't know. Okay, cool. So yeah, so now it's, I think I want to skip this because you've already done it, but I'll just go through it again, right? Let's cook. So we have the sine B here. This is angle B. Maybe I could say B beta, I don't know, just for vibes and J. We have sine B, here's the angle, and then sine B is actually opposite over hypotenuse, right? So now what's going on here? Okay, so now we have triangle ABC. It's a big triangle, not a right angle triangle. And then we construct our own hypotenuse. There is the perpendicular height, right? And then like, what is sine B? Sine B, we know it's opposite, which is our perpendicular height, divided by C, which is your hypotenuse, right? And we write H as a subject of the formula. We multiply by what? We multiply everything by C. The C, they cancel out each other, and that side is just multiplication. So you have a C and then sine B, right? And therefore, from here, you would say your area is half times A times C sine B, right? So this is just A, or half AC sine B, right? That's basically it. You can do the same thing with sine C. So let's go sine C. It's gonna be opposite, which is opposite. What is opposite angle C? It's H, right? H, which is your perpendicular height. So you would say H over B, right? Remember, B is your hypotenuse in this case, right? Now, what do? We write H as a subject of the formula. We multiply by B, and therefore H is equals to H is equals to B sine C, right? Now you're like, area of triangle ABC is equals to half base times, okay, let me not say base, let me say BC times perpendicular height, right? and you have half here, and then your base is going to be what? Your base is going to be A, and perpendicular height, there we go, this is your perpendicular height, it's B sine C, right? And you just have your area half AB sine C, right? Emphasizing exactly what we did, say like here on the previous slide. So I think we are done. This is the area rule. We are done. Just in summary, this is it. This is it. Yeah. So we're gonna do a couple of questions, and we'll call it a day for this thing. What is this thing? The area rule. Cool. Cool stuff. So we're gonna draw a sketch and then calculate the area of triangle PQR, ne? PQR, triangle PQR. So let me my face is hiding this thing. Okay, cool, that is fine. That is fine. PQR. So both of these A and B, they have the same triangle, like not the same triangle, but their triangle is both named PQR triangle. So let's start with the first one here. It doesn't actually even say that it's a right triangle. So here doesn't really matter how you do it, ne? But just for simplicity, let's just make right angled triangle, just for simplicity, nje. Right, so then you have your 30 degrees to your 90 and your 60 degrees, right? So this will be Q, and then this will be P, and this will be R, right? So now using that thing of small letters, so this is R, this is Q, and this is P. P is equals to 7, R is equals to what? R is equals to 10, right? So now I want to show you something. I think I didn't show you this thing. Let's go back. Which triangle should I use? Okay, I'm gonna use this one. Okay, cool. Let me use this one. So we did this thing for sine B, right? Here's the formula. The area of a triangle, we say it's what? AC. Look at where it's A multiplied by C times sine this angle. If we have this, you already know, like, this is just how you can easily remember the formula, ne? If we're talking about angle C, you would say it's gonna be this side A multiplied by, it's half multiplied by A multiplied by B multiplied by sine at this angle, right? And if ever then the angle is A, right? If this is the angle that you have, let me just call it theta. If A is the angle you have, then you would say area of triangle ABC is equal to what? Half multiplied by C multiplied by B multiplied by sine theta, right? So you're already seeing what, like, whenever you like, for when we use sine rule, ne? There's this thing. This is basically all you need, this is basically all you need. You need this angle, you need this side and this side, right? Or another one could be, you have this angle. Okay, and so you have this angle. My God, you have this angle, right? And then you have C, you have B. Do you understand? And then maybe just the last one, because now it's half times C times B times sine theta, right? Also here is the same thing, half times A times B times sine theta, right? Even if it's like this, even if you have something like this, even if you have something like this, you have this angle, you have D, you have F. To calculate here, it's gonna be area of a triangle is going to be half multiplied by d multiplied by f multiplied by sine theta, whatever theta is. So the reason I'm showing you is so that we won't spend much time trying to figure this out, because here you would then say area of triangle PQR is equals to half okay, it's gonna be half P or RP PR okay, it's gonna be half PR and then sine Q, right? That is half P7 multiplied by 7 multiplied by 10 multiplied by sine 30 degrees, right? Put that in a calculator. Half times 7 times 10 times 7 times 10 times sine 30, right? How much do you get? You get 17.5, right? Let me just say centimeter squared, just saying maybe we're measuring in centimeters. That was cool, yeah? Cool. For the second one, I'm sure you already, okay, if I we have done this one, I know that the area here, area of triangle PQR is gonna be half PQ sine R sine R, and then that will be half times 8 times 9 times sine 110, right? And then the final answer will be half times 8 times 9, and then you have sine 110, right? Then it will be 33.83, let's just say meter squared, right? But yeah, because you need two sides that are attached to each other. I want to say adjacent to each other, but two sides that connect and forms the angle that is given to you, right? So in this one, you can already tell that we might have a triangle like this one. You will have a triangle like that one. That is your 110 degrees, right? That's your 110 degrees, and this is R. Let me go for this color. This is R, and then this is P, this is Q, right? So in terms of the sides, this side is what is 8, which is P, so I'll say P equals to, and then this is Q equals to 9. Wow. Yeah, but yeah, Q is equals to 9. This is Q, and this side is just R. So what I was saying is, I'll remove these letters. What I'm saying is, you just need two sides that connect, and you know the magnitude of those sides. We have PR, we have QR. Yeah, PR and QR, they both connect to form 110 degrees, right? So you're just going to use them. Half multiplied by 8 multiplied by 9 multiplied by sine 110 degrees. Done and dusted. Do you know what I'm saying? You're killing this. So let's move on. Let me see. Whoa. Okay. Oh, that's the sine rule. So let's just do quickly these two examples. Determine. Beautiful work. Look at these people. Determine the area of a parallelogram in which two adjacent sides are 10 centimeters, and then 10 centimeters and 13 centimeters, and the angle between them is 55 degrees. Beautiful. Remember, a parallelogram. Now, what is a parallelogram? Parallelogram is a rectangle that has been pushed. Yeah, like parallelogram, it's actually a rectangle. But remember, a rectangle, all sides equal? No. Opposite sides are equal. All angles are equal, like 90 degrees. And you know what I'm saying? But then as for parallelogram, yes, opposite sides are still equal, but and opposite angles, yes, opposite angles are equal, because like now it has been pushed away. Only opposite angles are equal. We don't have all angles being equal. That is a parallelogram. Once you know that, it's gonna be so much easier to do this problem. Let's get done with it. So I don't know, it's like I'm feeling myself right now. So for this one, you have you just draw your parallelogram. It's gonna be something like this. Do you know what I mean? I will say not drawn up to scale. Okay, yeah, not drawn up to scale. Yeah, but I will just say A, B, C, D. So what do these people say? They are saying the two adjacent sides, right? They are 10 and 13 centimeters, right? That means the longest one is going to be 13 centimeters. You have 13 centimeters. Then you will have 10 centimeters. You have 10 centimeters, right? And then look at what they say. Look at what they say. They say the angle between them is what? 55 degrees. Do you understand? So I'll ask you a question. Do you think 55 degrees is going to be this one or this one? It's a very fair question, you know what I'm saying? Yeah, but of course, man, you know your geometry, man. Like, you're very good at this thing. You can tell that for this one, this side here, if I draw a straight line perpendicular to DC, right, you have 90 degrees right here, right? That means we have 90 degrees plus a couple of degrees, which makes it impossible for these angles. It makes it impossible for this angle and this angle to be the one that forms 55 degrees. We are quickie. So that means now this angle is the one that is actually 55 degrees. And remember what I said, parallelogram, opposite angles are equal. So you also have 55 degrees. This thing, guys, here you need to like get 100%. Like, I'm very serious, bro. Yo. Cool. So now you then realize something. For if you use the sine rule, you just need two adjacent sides that forms an angle, and you must know the magnitude of those two sides. You must also know what is this thing? You must also know this thing. Oh, come on, bro. The angle, you know what I'm saying? So now I'm gonna do this. Maybe let me take a green color. I'm gonna divide this parallelogram into two equal sides, right? So I divided it into half. So we have two triangles here. We have triangle AD, triangle ADB, and triangle BCD. Yeah, actually CBD sounds really cool. CBD. We have these two triangles, triangle A and triangle ADB. We have triangle CBD, right? And those two triangles, they are equal. So to calculate the area of this parallelogram, we will say we will start. First thing, you will start by calculating the area of the first triangle, and since the two triangles are identical, in a sense of they are identical, right? So the area of one triangle is the same as the area of the other triangle. That means to calculate the area of the whole parallelogram, we'll just say area. Let me go here. Area of a palm. Just for a parallelogram. So palm, area of a palm, it'll be, so I'm running out of space. So so area of a palm. Remember I said we have two triangles, so it's gonna be half and then base times perpendicular height, whatever it will be. But actually this is not, we're gonna use the sine rule there, but yeah, basically it's just half times base times perpendicular height, which is when you multiply by 2, it's base times perpendicular height, right? So that means that for us, we because we've already multiplied by 2, we're just gonna put the base and the perpendicular height. But you actually kind of know these things now. You know that the answer here, it's just gonna be what? Your base, you would say that is 13, multiply by 10, multiply by sine 55 degrees, right? And then basically that's it. 13 times 10 times sine 55, right? And we are getting 106.49 centimeters squared, right? This then will be your final answer. You are done, right? Just in case some of you guys might be confused, I will just take it step by step, right? And say for example, you calculate an area of triangle, area of triangle CBD. It's going to be what? Area of triangle CBD is going to be half, multiply by 13, multiply by 10, multiply by sine 55, right? This is the area of this triangle, right? So now you put that number, you know what I'm saying? You put it in a calculator, get your value, whatever is probably gonna be half of this. Now, since you have found the area of this triangle, and these two triangles, they are both identical, you will then say the area of a whole parallelogram is 2 multiplied by this, and that 2, it's gonna cancel this half, saying that the overall area is just gonna be 13 times 10 times sine 55, just like we have here, and then you are done. And just to do the last one, let me see if the area of triangle ABC, this is quite interesting. So let us do triangle ABC. So they say the area is actually 5,000 meters squared. With A, this is A, so A is equals to 150 meters, and then B, this will be B 70 meters. What is okay, what are the two possible sizes of C? Cool. The question is, what are the two possible sizes of C? I think here actually I did a mistake when I wrote this. I'm just gonna check it right now. I will check it, but I think I didn't mean to do two. But let me stop speculating on what I was trying to do and what I was not trying to do. But let's get done with this problem. Yeah, let's get done with this problem. So you would say the area of triangle ABC is equals to, I'll just check if I did a mistake by saying two possible sizes, or maybe did I don't know, I'll check. So it's gonna be half A times B times sine C, right? So we're trying to find the angle of sine C, and now they tell us that the area is what, 5,000. I'm not gonna put the units. You have half times 150 times 70, and then sine C, right? That means on this side you will have 5,000 divided by, do you know what I'm saying? I'll just say 150 150 times 35. Yeah, 70 and a half, 35. Right, so go 5,000, 150 times 35. 35. Oh, actually, I don't even maybe have to do it now, but sine C. And then now I will just say sine minus 1, 5,000, 150 times 35. That will be angle C, which is shift sine 5,000, 150 times 35. We're getting 72.25 degrees, right? Yeah, so that is the value that we're getting. That is the value that we're getting. And maybe also here, just for the satisfactions of those who may not be happy, I can say 1/2, 1/2 times 70, right? And I close the bracket. I'm still getting the same answer. Yeah, so I'm gonna post the video just now just to see what actually happened, if it's too possible, or we just end it there. All right, cool. So I just checked. So there's nothing wrong with the question. So yeah, now we can apply we spoke about, I'm trying to remember this reduction formula. So with when we're doing reduction formula, we was like, for sine, so we're talking about sine here, of course, and of course our sine is positive. Then you ask yourself, where is sine positive? Also in your Cartesian plane, it's positive in the third quadrant. The second quadrant, where we have theta being, or where we have 180 minus theta being your possible angle, your possible angle. So therefore we have theta, which is 72.1. So we could say another angle for C, it will be 180 minus 72.49, which is 180 minus 72.49. Oh, not 49. Oh, the 49 was for this one. The 49 was for that previous example. 25. So 25. Yes, we have 107.7 degrees, right? And what we can do now is assume let's try to see if when we do the sine rule thing we'll find actually 5,000 for both values. Now just to see, right, we have half 0.5 times 13, times 150 times 70 times sine 72.25. Look at the value we get. Rounded to the nearest whole number, we're getting 5,000, right? And let me make 107.25. Okay, so for this one, I'm not so happy, ne? Yeah. For this one, I'm not happy with. I'm not happy with, but oh no, this is actually 75. Is this 75 or 25? Wait, shift sine. My handwriting is so bad I can't even see it. 150 times 35. Yes, 25. Oh yes, I get it. 0.5 times, I get it. We still on the right track, and I'm still happy. Times 150 times 70. and then times sine 107.75, because we minus the 5 and we're getting exactly the same. It's exactly the same. Round it to the nearest whole number. You have it right there. And that, my friend, is the end of sine area rule. Thank you very much, and I'll see you in the next video.